Hi, Ellie. How are you, dear? Listen, I wanted to make a video answer for this because it has graphic in it, and I wanted to show that in graphical form as well as calculations because you can't really show that on the board. Okay, so I made this video for you to watch. Anyway, this should be the solution of that problem that you got for that plane moving south. So the plane is moving south at a speed of 200 miles per hour. So write that 200 miles per hour. So when we say moving south, that means it's moving in the negative j direction. Okay, so this is the negative j direction, and this is the positive I direction. Okay, so which means that the speed of the plane initially you can write as minus 200 j mile per hour. Okay, that's one. Now, when it was flying, the wind hit the plane, and now it caused it to move to a position b vector equal to 45i minus 170j. Okay, so if we are to sketch this vector on a Cartesian system of ordinate, let's just say that each one of these sticks is 40. So that's 40, 80, etc. up to 200 here. I'm not drawing this to scale, but I'm just going to draw in close measurement so you can see the vector and how it kind of shows. Okay, your I component for the B vector, and that now I'm going to draw in different color. The I component for the B vector, I'm going to draw in blue. This is the I component of the B vector, and it has a magnitude of 45. So it's positive 45. I'm going to write here 45 I. Okay, because this is the x-axis and this is the y-axis, and that means this is east, west, south, and north. Okay, so the vector has a component of 45i minus 170j, so that's 40, 80, 120, 150, 170, somewhere here. So if I draw this vector here, like so, that will be minus 170 j. Okay, so first of all, we need to find the resultant of this vector, because the resultant of the vector is going to show you the position of vector b. So vector b, we know vector s how it's going, but vector b has two components, I and j, so we need to find the actual resultant of vector b. Okay, so vector b, the resultant of vector b is going to equal to square root of, well, before we do that, let's just sketch the vector here. So sketching the vector, we complete the parallelogram, or we complete the rectangle, whichever way you want to call it. This looks like a rectangle because the x and the y components are perpendicular to each other right here. So they are perpendicular to each other. So which means that starting from the origin, starting from the origin, I could draw my resultant vector like so. Okay, so that's going to be my resultant vector r of vector b. Okay, and that is the direction of the plane after the wind hits it. Okay, so to find this value, this is the angle we need to find. Okay, this angle is rotating clockwise from the x-axis toward where the vector r is positioned. So that angle, first of all, we need to find the magnitude of RB. The magnitude of RB is what? The square root of 40 squared plus minus 170 squared. Correct this. This is actually 40. So that will give you 176.4 what? We don't know. Mile per hour, right? That's the velocity vector RB after the wind hits the plane. Okay. Now, S is given also is already given in vector form. Okay. So if I want to find theta, which is this angle here, that will be tangent inverse opposite over adjacent. So it will be theta will be tangent inverse. What's the opposite? It's this component here, which is what? Minus 170 over adjacent is 40. So take that and find tangent inverse minus 170 over 40. You get minus 76.8 degrees. And notice you got a negative because the rotation clockwise from the x-axis toward around the Cartesian system of coordinate is a negative value, because positive is counterclockwise plus and negative is clockwise. Just want to clarify this point, why you got negative here. So this is a position of vector RB of the plane after the wind hits it. Okay. So, but he wants the wind vector that hit the plane and caused this vector to act to be like that. So this vector RB is a result of the plane vector S plus the wind vector, which we do not know what it is yet, but we will. Okay. RB is the final condition or the final position of the plane, is a result of the actual vector of the plane moving south plus the wind. So if we want to find the wind, it will be vector RB minus vector S. Okay. We know what vector RB is, which is 40I minus 170J. Okay. And we know what vector S is. It's minus vector S, which is minus 200J. Okay. So now we add the I and J components, we get 40I minus 170 plus 200 is plus 30J. Okay. So we know what the component of W is now. Let's sketch them here. Okay. So the component of W will be, let me use a different color here. Let me use this color. Let me use magenta. So it's 40I. So let's draw this. This is 40I. It's just the I doesn't really change. It's just notice that the I does not really change at all. in all the vectors, the same. 40i plus 30j. So plus 30j is up, right? So we said this is 40. Well, this is plus 30 here, say. So plus 30j is up like this. Plus 30j. And the resultant of this vector is what? If you complete this parallelogram, or in this case, it's a rectangle again, because like I said, the x component and the y component are perpendicular to each other. You're going to get the resultant vector. I'm going to draw also in magenta, like this. And this is Mr. Vector W. Okay? And that's 40i plus 30j. Now, if you want to know the magnitude of vector W, let me write in blue. The magnitude of vector W is what? Square root of 40i plus 30j. So 40 squared plus 30 squared. Let's see what we get. Square root of 30 squared plus 40 squared. Oh, yeah. Hold on. 30 squared. I got 50. 50 what? Mile per hour. That's the speed of the wind that hit the plane to cause it to basically change direction from going due south at 200 miles per hour to this vector RB in this direction. Okay, the magnitude we found. If we want to find the angle, now notice we're going clockwise. We're going counterclockwise, which is positive angle. So the angle here, and let me draw that in big so you can see it better. So this is your resultant, which was a W, the wind vector. And we know this is the angle theta. And like we said, we're rotating counterclockwise. Therefore, I expect the answer to be in positive. Positive. Okay? So what is this height? This height is what? 30. Okay? And what is this? This component is 40. So it will be the position, theta, will be tangent inverse 30 over 40. So 3 over 4. So we'll find out what this is in a second. And of tangent inverse 36.9 degrees. So this angle theta here is 36.9 degrees, which means that the wind vector that hit the plane has forms an angle of 36.9 degree positive with the horizontal, rotating counterclockwise. Okay, that is all the answers, and I hope you like this video. And if you want extra help with something else, just look me up on Wyzant. Take care.